Unit 6, Lesson 2, Special Right Triangles. Your objective for this lesson is to apply properties of special right triangles to solve problems. Okay. There are two types of special right triangles. Let's start off with the 45-45-90 triangle. As it turns out, there is a relationship between the sides of a 45-45-90 triangle. It's a ratio, and it holds true for every single 45-45-90 triangle. So a 45-45-90 triangle has one 90-degree angle, so that's the 90, and two 45-degree angles. So it is an isosceles right triangle. And you can see here that the ratio of our sides is x, x, and x square root 2. It should be like that. Okay. X times the square root of 2. So each side that is across from one of my 45-degree angles, so those two angles that are the same, the sides opposite them are also the same. Remember, that's just an isosceles triangle. The hypotenuse is that length times the square root of 2. You might also see this instead of x root 2 as 1 square root 2. The 30-60-90 triangle is another right triangle, but then it also has a 30-degree angle and a 60-degree angle. This one is a little bit more complicated. So the side across from the 30-degree angle is always x units long, or 1x units long. The side opposite the 90-degree angle, so the hypotenuse, is always 2 times x. And then your third side, so across from the 60-degree angle, is x times the square root of 3. The way that I remember these two, and it might help you, it might not, but this is just how I remember it. So on the 45-45-90 triangle, I have two different angle sizes, either 45 or 90 degrees. So I have two different side lengths. I have to have a radical. So for both of these, you have to have a radical. Here I have 1, 2. So 1 square root 2. Yeah. So, and just like I have two sides, this is a 2. So two different side lengths, I should say. There's 3 sides, but two different side lengths. So x square root 2. And this one, I have 1, 2, 3 sides. So let's try that again. 1, 2, 3 sides. So I'm going to have my ratio of 1, 2 square root 3. And 2 is bigger than the square root of 3. This is like 1.7 something. So it has to be the hypotenuse. 1, 2, 3. 1, 2 square root 3. Okay. Example 1, we want to find the missing side lengths, and I have 3 parts to this. Yes, I do. Okay, so find the missing side lengths. Well, this is a 45-45-90 triangle. How can I tell? These two marks tell me that those side lengths are equal, which means that the angles opposite them are also equal. The only way they're going to be equal is if they're both 45 degrees. So this means I have x, x, x root 2. You do need to memorize the ratios of the sides for these triangles. X, x, x root 2. So I know 20 is x root 2. Okay, so what is x? Let me divide by the square root of 2. Okay, so right now I have x is 20 divided by the square root of 2. But there is a rule in math that says that you cannot have a radical in the denominator. So we're going to multiply top and bottom by the square root of 2 divided by the square root of 2. So multiplying by this. Why? Well, if I have the same thing top and bottom, that's like multiplying by 1. So I'm not really changing this. But I'm going to multiply straight across. 20 times the square root of 2 is 20 square root of 2. Divided by square root of 2 times square root of 2 is 2. And now we're almost done. I see I have a 20 divided by 2. I can simplify that to 10 square root 2. And that is my missing side length. Okay? So right here I have 10 root 2 and 10 root 2. Okay. Part B. This one's a little bit simpler. So again, I have x, x, and x root 2. So I'll show you the way that we just did, and then I'll show you the shortcut. So the way we just did, we said 15 square root 2 equals x square root 2. We're looking for x. And again, we know this is the pattern because these sides are marked congruent, which means that I have a 45, 45, 90 triangle. To get the x by itself, I need to divide by the square root of 2. So those cancel. And I can see over here that those cancel. So 15 is x. 15 is my missing side length. Okay, so what I could have done, my shortcut, is over here, I know that this side is x times the square root of 2, and I actually have a square root 2 right there. So I could just cancel that and get my 15. I could just exit out and get the 15s for right here. Part C. Okay, so again, I have a 45, 45, 90 triangle because of those marks. And I'm looking for these two sides. Well, this side is a 3, which is the same as this bottom side here, so I can just mark that as a 3. And I know my ratio is x, x, x root 2. If 3 is x, I can just plug that in. So I have a 3, and that is what my x is. So I'm going to say this side is 3 times the square root of 2. And I'm done. Okay, example 2. I want to find the missing side lengths again. This time I don't have a 45, 45, 90 triangle. Notice that none of the sides have been marked congruent to each other. I do, however, have a 30, 60, 90 triangle. I can tell I have this 60 and my 90, which makes this 30. Remember, the ratio of our sides is going to be, I'm going to have an x, a 2x, and an x root 3. 1, 2, 3. The short side is 1x, and that's across from the smallest angle. Smallest side, smallest angle. The smallest angle here is 30 degrees. So this is my x. 2x is the hypotenuse, so that goes here, across from the 90-degree angle, which makes this x root 3. Oh good, I already have that root 3 right there. So I need to find x basically because I have those two sides. There's two ways I could do this. I could use either one of these sides. So I could say, because I'm looking for x, 16 equals 2x, and divide by 2 to get x is 8. I could also use this part over here though. See, they both have the root 3. I can just get rid of those, and x is 8. So my missing side is 8. And I got it both ways, so I know that it's definitely right. Okay, part B. We have another 30, 60, 90 triangle, which again we can tell because we have this 60-degree angle. So this is a 30-degree angle, and this box, of course, is 90. And our ratio of our sides is 1x, 2x, and x square root 3. 1, 2, 3. 1 goes across from the 30-degree angle, so this is x. Oh, since we have x, our life is very easy here. And then 2x is always the hypotenuse. X root 3 is that other side, the long side across from 60 degrees. So really, I have the 2 of the 3 sides. I need to find 2x. The fastest way to do this, since I have x by itself, is to just multiply that by 2. So x is 5. So 2x is 2 times 5, which is 10. So this side length is 10. Or the hypotenuse, I should say, is 10. Okay, last one, part C. And we only have one side length given to us here, but that's okay. We can find the other two just fine. Just remember your ratio. 1x, 2x, x root 3. So this is 30, which means this is 60. Here's 90. So x, 2x, x root 3. Okay, so I'm going to set up my equation. 2x equals 24, because it does, and divide by 2. So x equals 12. Now that I have x, I can just put that onto this side right here. And that one's done. And x times the square root of 3, I just have to tag a square root 3 onto the end. And it's done. Oh, and that wraps up lesson 2 for us. Don't forget to memorize those ratios of sides.